How's it going, y'all?
Well,
Nice. Awesome. Well, feel free to join. I see some folks trickling into the call. Feel free to grab a cup of tea, grab your coffee. We'll start in about 30 seconds to a minute. So, see some more folks joining. Awesome. Well, I'm really excited. I see, I think most people have joined by now. We have some pretty good numbers. I'm really excited. We have Crystal on, we have Andre on. Andre, you've been on before. Crystal, this is actually your first time on. So I'm really excited to have you both here and talking about this golden thread discussion, really honing in on this early warning system that we've been developing here. So before we get into that, though, I want to step back and give a quick overview for the audience of where we're going today. So, Crystal and Andre are going to be walking us through this early warning system topic. We're going to spend about 5 to 7 minutes just doing a roundtable discussion on what's exciting them in this world of protecting developer ecosystems, really looking holistically across these infrastructures. And then we're going to move into this use case around actually detecting attackers' movements, starting from a developer laptop into your AWS runtime. And looking at how an attacker is trying to prod and probe across these either GitHub accounts or Okta accounts. So I don't want to spoil too much. I'm excited to get into it all. And we have a lot to cover. So, Andre, I'm just going to go ahead and start with you. We see headlines time and time again of attackers really trying to infiltrate these developer ecosystems, maybe exfiltrate Git repos, or big headlines around attackers getting into production. For you, why does this problem of really protecting developer ecosystems continue to persist?
Yeah, as the world has moved towards trying to get smarter and automate and develop more, the developer has become critical within that supply chain, meaning, they are in the forefront of writing code, testing code, developing code, which is used for, almost everything we touch and use in today's world. So because of that access that they have and the visibility that they have, attackers are targeting these developers because they know that if they can get into the developer's laptop, there is a very high chance they get access to the code repositories that hold the source code for, other nefarious activities.
No, that's fantastic. Yeah, and it's really that idea of these developers are the ones crafting your crown jewels and really crafting the code that moves its way into production. Crystal, we call this an early warning system, detecting before these crown jewels get accessed or exfiltrated. What are some of the building blocks that we as security practitioners need to think about to be able to even detect early on?
yeah, coming from a development and DevOps and kind of cloud native background, I always think about it in terms of kind of build, deploy, and workload. So you need to understand what's happening with your developers at the build stage as they're moving code in and out of repos. So that's a huge piece of that. You need to understand the identity of whatever threat actor is behind malicious activity in your environment, because you don't know, it could be an automated kind of botnet attack, or it can be an individual actor kind of spear phishing, right? And running more targeted attacks. So I definitely think those are two pieces. There's a little bit more to it. I think, particularly as it pertains to what we're presenting today, those are the big pieces for me.
No, that's fantastic. And that's kind of what we're looking for on the defender side. I'm curious then, Andre, if you could give us a little bit of insight. What are attackers looking for when they perform lateral movement? What are really the goals of an attacker as they move around?
Yeah, first and foremost, they're going to want to get the most permissions they can get in an account, because if they are able to acquire highly permissive roles, users, or attach those highly permissive policies to a role or user, it reduces their friction as they begin to, navigate through an environment. So they may not be able to achieve that outcome by going directly to a particular service. So they may have to move laterally to be able to move, excuse me, ahead. But they're looking for, I like to say these little cracks, right? Little cracks in the system that they're going to exploit and move through to be able to move on to the next desired outcome, which again could be exfiltrating data, ransomware, creating backdoors. There's a lot of different outcomes that they're trying to achieve.
No, that's perfect. And I love your analogy of looking for these tiny little cracks as they prod and probe across our environment. And I think that's just a perfect segue into the use case itself. So, without further ado, I'm going to go ahead and share my screen and let's go ahead and take a look at this use case that we've put together. So, kind of stepping back a little bit, we want to really bring together data from across your environment. So for this attack today, we're going to be looking at these 4 asset types. We're going to be talking about the developer laptop, identity providers, looking at some GitHub code repositories as well, and then looking at how an attacker might move laterally into your AWS runtime or any cloud service provider and actually try and perform that exfiltration step. So Crystal, I'd love to kind of hear your thoughts on this as we begin the use case on, where these breaches often start and just a little bit of background as well.
Yeah, totally. Thank you. So on this slide, we're really talking about how a lot of major breaches really start with the developer's laptop. And again, like I said, coming from a cloud native background, AppSec and DevOps teams in particular don't have a lot of insight or visibility into developer laptops, right? So there's this huge silo and gap. And so we forget that the laptop is also part of developer security, right? So we see these threat actors now targeting the laptop. And so that's what we're going to take you through today is what we call kind of this golden thread attack, which watches a threat actor as they kind of traverse from actual laptop through identity provider, trying to make headway there. But again, like Andre said, they run into friction. That friction slows them down. So they kind of pivot, go to GitHub, and move through here. So I think it's really interesting. I think it's particularly prescient because we're thinking a lot about our runtime workloads. We're thinking a lot about vulnerabilities and misconfigurations. And sometimes we forget just tracing from endpoint to actual code deployed at runtime in the cloud, how much can be missed in the way attackers exploit those cracks and those gaps. And here, so there's a little lag, but yeah, here is what we call kind of our cloud security early warning system, which is where we've introduced features around Okta and GitHub. So you're actually monitoring what your developers are doing as you're moving code from repos into production. And so you're gonna understand that a threat actor is in your environment far ahead of them accessing your cloud workloads at runtime.
Cool. So yeah, let's get into this. As you can see, and what Crystal and Jeremy have mentioned, there's 5 stages to this attack. The very first stage that we're highlighting, we see some malware getting downloaded onto a developer's laptop. And, this is happening more frequently than we'd like to think. An example of this, nation state actors have impersonated companies, hiring managers, and sent job offers to candidates. And as soon as they open the job offer, it's executed malware. So what we're seeing here is initial access, developer downloads malware. And then if we go to the next slide, what we can see in the next slide is the actual attack happening. So here's the attacker, Netcat, opening up a port, listening on 443. And essentially what this is doing is once the developer has opened up the malware, it's created a reverse shell back to the developer's laptop. Back to the attacker's laptop. The attacker then goes ahead, looks through a couple of files, trying to find credentials, and they find 2 sets of credentials. First is the GitHub personal access token, and then second was the Okta clear text password, username and password for Okta. Next slide. One of the key areas and benefits we at Uptycs have is we are pushing our telemetry, the telemetry of customers into our Uptycs cloud. And that's across all of these technologies that you're seeing here. So we structure it, normalize it so that we're able to get you near real-time alerts based on one or more of activities happening within these technologies. So this is what the Uptycs console would look like. So if this reverse shell were executed, this is how it would show up inside the Uptycs console. As you can see, JHAL laptop spawns a process, reverse shell, and then on that reverse shell, you can see from the attacker, they've gone and opened up the Git credentials file. So we have a replays feature that you can replay this. So as you look back, you're able to see what the threat actor did and what all they accessed on that particular laptop. So now that the threat actor has credentials for Okta and for GitHub, their first attempt is going to use the clear text password and username for Okta. They see the chiclets, they try and access the chiclets, but they're prompted with MFA. The threat actor doesn't have MFA, so they've hit a dead end. But again, threat actors are very cunning and very resourceful. Because they were able to access a second set of credentials for GitHub, they now pivot and go the GitHub route. Before that happens, what we can detect within the Uptycs user interface is the anomalous session or the impossible travel for that particular user. So what we're seeing here is the developer was based or is based in the US, and the threat actor is based in India. Because the developer was still logged in and the threat actor also logged in, but from two different IPs in two different regions, geographic regions, we're flagging it to say that we have a Okta session, anomalous session, where a particular user, James Howell, has been logged into from two different locations. And again, we're uploading the Okta telemetry into our cloud, and we're able to detect for that impossible travel in our user interface. So now that the threat actor has hit a dead end with Okta, they move on to GitHub. And, again, GitHub is a very, very resourceful target for threat actors. The reason being, it's source code. That source code can hold secrets. That source code can be manipulated to include or inject malicious code. So as they upload it, it has malicious intent behind it. But what we'll see is how the threat actor was able to find a file in the developer's Git folder. Let's go to the next slide, Jeremy. So again, threat actor has access to developer's laptop. They find a AWS dev Jenkins file. And on this file, they show any remote repositories associated with it. Using the fetch URL, the threat actor is able to clone a particular repository to the threat actor's machine. So essentially what they've done at this point, use the credentials for the developer, found a repository of interest, and cloned that repository to the threat actor's local machine. They now look through the code, and in the code, they find actual AWS keys. So very common for developers to store access keys inside code, and using that method, the threat actor has uncovered and searched for a key and secret access key, And that is what they're going to use to pivot into AWS. And again, just to validate, we upload the data into our cloud, and as we'll see on the next slide, we can actually detect for a suspicious Git event, excuse me, from an anomalous location. So really what should be happening is these Git events should be coming from the same source IP, the session time should be the same or similar within the day. But what we found is that the session or the Git event has come from a location that is different to what this user normally performs Git events through.
No, this is awesome. And just to kind of pause for a moment, one thing that you had talked about on the previous slide was a threat actor trying to steal some maybe embedded secrets in code. And it's a little tangential to our use case story here around kind of tying this telemetry together. But another really strong use case that we've been working on at Uptycs is embedding ourselves deeper into the developer pipeline to really scan for these embedded secrets and scan your registries for vulnerabilities as well. So I didn't want to let that go by without dropping that. But no, thank you so much for
good
walking.
point. Yep. Yeah, very good point. Okay, so at this point, the threat actor has found the access key, secret access key for a particular user. What they are now doing is they will attempt to identify who the access key belongs to, which IAM user, and then they'll determine what permissions they have and how to escalate their privileges or their permissions. So if we go to the next slide. So what we see here is the threat actor configuring the AWS CLI with the stolen credentials. Once they've done that, they will identify who the user is, who those credentials belong to. They're then going to list all the policies associated to that user. They're then going to identify how many versions that particular policy has. And going through each version, they're going to identify which version is the most permissive. The reason being is they want, as much permissive permissions as possible, so they don't have run into friction. As you can see here, version 3 is the most permissive. So they've now set version 3 as the default policy version. Thus, they've escalated their privileges to full admin in AWS. Next. And again, right, we can detect for that. So everything you store on that CLI, we can detect for. So we will surface it to you. Actually, go to the next slide. We will surface it to you in a very simple and meaningful way. So as you can see, get caller identity, list attached user policies, list policy versions, get policy version, set default policy version. But what's very, very important is the what on the right-hand side. We're explaining to you in layman's terms what just happened in your AWS account. And we're giving you additional metadata. We're giving you timestamps. We're giving you access to the CloudTrail event so that you can look at that and go and perform additional investigation, or you can go ahead and remediate, which, steps to fix, as you see, we'll give you explicit instructions on how to remediate this particular event that happened in your account.
No, this is perfect. This is, these dashboards are some of my favorite in the platform just because of the level of context that you get. Looking on the right, we have this kind of a, plain language understanding of what's going on. But on the left, you have such a strong understanding of what policies and what actual IDs and AWS calls triggered this event. And you combine that with the policies down below with that actual code level detail. So I really enjoy getting to see these and getting to understand not just what happened, but why we alerted and what steps we can take to remediate it.
Yeah, and the other thing this does is it teaches security teams who utilize our product how a threat actor thinks, right? So not many security folks, if you were to say, how do you escalate privileges, right? What are the specifics? What are the exact APIs you would call? Many folks are unable to answer that. But what we're doing is we're showing you that sequence. So your security team is now aware that, if they are going to have multiple versions of a policy, this could potentially happen.
Perfect.
And then finally, as you can see the journey, we've come from the developer's laptop into Okta, we've hit a roadblock, we've pivoted, we've gone to GitHub, we've cloned a repository locally, we've scanned that repository, we've found some secrets in the code, we've used those secrets to access AWS, we've escalated our privileges within AWS, and now we want to exfiltrate data. So what we're going to see is how a threat actor will exfiltrate data via AWS. And we're focusing on RDS instances. So they describe instances, they identify a production customer's database, they make another call to understand some additional metadata associated with that database. From here, they create a snapshot of that particular database. Once the snapshot is completed and it's ready and available, what they're going to do is then modify the attribute from that snapshot. And really what they're doing there is that attribute that they've modified is a different AWS account ID. So an attacker controlled AWS account ID, they're able to share that snapshot with that account. They then log into that account and they can restore RDS database from this particular snapshot, and they'll have access to all of the data on that database that was originally in the victim's account. And again, all of this data is uploaded into the Uptycs cloud, where we structure it and normalize it in a very concise way that enables us to provide you with a very clear understanding of what just happened in the account. So as you can see on this next slide, just like we saw with the privilege escalation, we're able to see what just happened, describe database instances, create database snapshots, and then modify DB snapshot attributes. We're giving you all the metadata, the access key, the remediation, the user agent, source IP, has it been seen in your account in the trailing 3, 4, 30 days, whatever your data retention policy is, so that you and your team can take action and determine what's best to do with this particular event.
No, this is fantastic, and I'll kind of like keep talking kind of on this slide a little bit as it's playing through. But thank you so much, Andre, for really walking us through this use case. It's fantastic to see not just bringing this data together, but bringing it together in a really meaningful way to be able to detect early on and give us that early warning system that Crystal was talking about, where we don't have to wait until our runtime or these credentials get stolen to actually alert. We can catch this early before the code gets tampered with or before the GitHub repo gets actually accessed. So I'm going to stop sharing right now and kind of open it back up to that Q&A section. I did see a couple questions come in, but just as we're kind of waiting for those questions, Crystal, any thoughts after seeing the presentation again? And Andre, really good job. Fantastic.
No, that was great. Thank you so much, Andre. I really will say it really always sticks out to me, just the amount of silos that exist and how, as we see like a rise and increase in social engineering and these attacks that are much more sophisticated, how vulnerable our endpoints and laptops can be. I was always under the impression I have a Mac, I'm safe. And I don't know that that's necessarily true still.
Yeah, no, that's fantastic. Okay, so one of the questions I saw come in was maybe for Andre, you can take this one. So we saw these different pieces. What are security teams actually looking for when detecting lateral movement? Is it these API calls? Are we maybe connecting IP addresses as they're going back and forth? I know you really just walked through this entire use case. But yeah, what are we on the security side really kind of looking for?
Each team is going to be different. From a security team that is protecting their infrastructure, their data, they're looking for anomalous behavior. And a lot of the time that's looking for a needle in a haystack because of the ephemeral nature of cloud, as an example. There are so many changes and so many events getting fired to be able to kind of sift through that and really find, was this API call legitimate, or was it a threat actor trying to move laterally, trying to escalate their privileges? The great thing about what we've done is we have put our threat actor hat on and said, how would a threat actor do this? What steps would they employ? How do they think? Right. So we have a team of researchers who attack clouds day in and day out, and then we reverse engineer that to say, here's how we should detect for it. Here's how we should help security teams get better at their role.
No, that's fantastic. And I think there is something you're hitting at here, which is the uniqueness of every environment and really tailoring these solutions to those environments and really bringing out value in each person's unique infrastructure. Okay, one final question, Crystal, I saw come in was kind of talking about developer ecosystems. And I know that you have been a developer yourself. So I'm just kind of curious, in your mind, why is it so important to monitor these different pieces specifically in the development ecosystem?
I'm going to be honest in that it's been a few years since I've been a developer and it's constantly changing. And I think that's probably the reason why it matters so much is developers are constantly looking to innovate. We don't want friction. We just want to solve problems well and efficiently. And security just tends to be kind of the last thing on your mind. And what we're witnessing now, this DevSecOps revolution where we need to build security into everything, developers need to be pulled into that as well. And right now we've been operating outside of securities, I think, purvey. And so that's why I would say, regardless of the current tooling people are using or, the current infrastructure and implementations, you need to always be aware of the developer ecosystem. And right now, GitHub is really huge where it's at. Obviously, a repo is what we're going to be using on the day-to-day. So yeah, that's just my kind of rambling on
And
that.
one thing to add on this, developers are not security engineers. Oftentimes there's this mantra to say they need to think security, they need to be security minded. That's very, very difficult for a developer to do because security equals friction in their eyes. And their priority is developing something and getting it out the door. So using tools like Uptycs can allow developers to continually go and be developers. With us as your eyes and ears, we can help oversee that security lens that'll help them continue to develop and not have to worry about, are they being secure. Obviously there's a sense of responsibility, but developers overall are just not going to focus on security for the most part.
Yeah,
Absolutely. And sorry, can I extend it a little longer just because that was such a great point?
please do.
Which
Yeah.
is okay, yeah, totally. It's even if we live in a perfect world where all developers have adopted security and it's built through everything, it's such a big ask, and we're not there yet, and it'll be a while until we can get there. We really have to make everyone so security aware, right? Everyone needs a deeper security training than we get right now. So yeah, to Andre's point, let's help your developers adopt security, right? And a tool that is able to not only see everything, but then actually give advice and map that to things like the MITRE ATT&CK framework. It's almost like, it's a little cheesy to say, but it really is like having another team member on your team.
And one more point. When I was at AWS, the famous saying was, "Good intentions don't work." Right? You have good intentions, or a team has good intentions. Don't rely on that. Mechanisms are what's going to help you succeed. So, developers have best intentions, but don't rely on their intentions. Have a mechanism or two or three that enables you to have that oversight, detection, visibility. Just going back to the attack, if this attack would have happened on an Uptycs developer laptop, we would have killed the reverse shell. So the entire attack that we saw would have been prevented because we would have A, detected it, and B, immediately killed that reverse shell using the Uptycs sensor. So either have the entire attack convert or traverse, or find it at the source, kill it so that the threat actor cannot continue or persist in their attack.
No, this is fantastic. And to kind of cap off this webinar, I really just want to say thank you both for joining and giving us so much insight. I have really enjoyed having you on. I can see some of the comments and feedback already have really enjoyed talking with you. If anyone on this webinar wants to continue this discussion, please feel free to reach out. All three of us love talking about these topics. We love evangelizing this, and we love just engaging with practitioners. So if any of this resonated with you, or even if it didn't, please come find us, let us know after, and we're always around. So I just want to say thank you so much to Crystal and Andre for joining us. Thank you so much for all of you for being such a fantastic audience. And yeah, feel free to reach out to either of us, and looking forward to seeing you next month. Thank you all.